Welcome friends, we have started three movement theorem from our previous two lectures. Okay, we will continue the same topic in today's lecture also. So before we will start with the actual numericals on three movement theorem, so I will just elaborate about the shortcut key for the calculation of a1x1 divided by L1, 6a1x1 divided by L1 term in three movement theorem. Okay, so now for the university exam there may be some multiple type questions if the exam is online exam. So in that case you have to find out the value of moment by using three moment theorem equation, and you have to find out this value in a very short time. Okay, so in that case we should know some shortcuts to find out the different terms, which is a little bit complicated. Okay, so for in today's lecture, during the first half, we will see one shortcut key for the UDL. If the uniformly distributed load is there, as shown in figure, for the two different span of continuous beam, but the intensity of both the UDLs are different. Okay. So now, how will you find out the term that is a1x1 divided by L1, 6a1x1 divided by L1 plus 6a2x2 divided by L2 in the term of three moment theorem. So now the three moment theorem, let us say for if you apply for this particular beam, it will be MA into L1 plus 2MB into L1 plus L2 plus MC into L2 is equal to 6A1x1 divided by L1 plus 6A2x2 divided by L2, provided that the moment of inertia is constant across this span. Okay, the moment of inertia is not given, it means it is constant, so definitely it will be removed from the all terms of equations of TMT. Okay, now I will give you the shortcut key or shortcut formula to the 6a1x1 divided by L1 when this UDL is given in the beam. UDL is given in the beam. Now we will try to find out for this one. Okay, and this is a simply supported span. So the continuous span of beam with two spans, and one is carrying UDL W1 and second is carrying UDL W2. Now if you draw the PPMD for this beam, so PPMD will be like this, because first is UDL, so it will be parabolic and its magnitude, maximum magnitude will be W1 L square divided by 8. This is also parabola and its magnitude WL2 square divided by 8. Okay, so now try to find out a1x1. Try to find out a1x1. So a1 is area of this parabola, which is 2/3 of base will be L1, and apex is W1 L1 square divided by 8. Okay, and its CG will be at L by 2, because parabola is symmetrical parabola. The CG will be at a distance L by 2 from A. So, okay. Now it's a 2/3. Now see, 8 multiplied by 2, 16 multiplied by 3, it is 48. It is 48. Then this L1, L square and L. So it is W L1 raised to 4. L1 raised to 4. So a1x1 will be, if you solve this, W L1 square divided by 20. And divided by 48. Okay. So now similarly, if you calculate for the second case, this will be second case. A2x2 will be. Now this is W1. For A2x2, it will be W2 L2 raised to 4 divided by 20 because this is also UDS. Okay. So now what is this 6A1 x1 divided by L1? We have to find out alternative formula for this. 6A1 x1 divided by L1. Now this A1 x1 we have calculated. Okay. So it is 6 divided by L1. L1 x1 is W1 L raised to 4 divided by 22. Okay, now this L1 and this 1 L will be get cancelled and 6 and this is 24. So if you solve this you will get W1 L1 cube divided by 4. And for second 6 L2 x2 divided by L2. This will be W2 L2 cube divided by 4. Okay. Now, when the UDL like this will be given on both this span, you can use this formula. So instead of calculating A1 x1, calculating separate this WL square divided by 8, you can directly put this value as W1 L1 cube divided by 4 plus W2 L2 cube divided by 4. So in just one equation you can calculate the value of this MB. You can calculate this value of MB in very short time. Okay. So now we'll practice one example from this. Okay. This is for particular case when uniformly distributed load is there, okay? Not for every case it is applicable. If the point load is there, then you have to use general equation of 3 moment here. Now see the numerical. A beam ABC of length 16 meter consists of spans AB and BC each of 8 meter. So ABC beam of 16 meter and each span is 8 meter. Each span is 8 meter. Okay. Now it is simply supported at A, B and C. A is also simply supported. So either those are on beams. B is also on C. As A and C both are end support with simply supported. A and C end supported means simply supported. It means the moment at A and C will be 0. So MA and MC will be 0. End support जर फिक्स असेल तरच तिथे मूवमेंट येणार आहे, otherwise 0. Okay, please note this. Now the beam carries a uniformly distributed load of 40 kN per meter over a whole length. पूर्ण length वर 40 kN per meter आहे. It means W1 and W2 both are same. Find the reactions at support moments. Means we have to find out the support moment and reactions. Okay. So if you want to calculate the support moment, you will get support moment just in one equation. Okay. Now just you have to substitute everything. MA is 0, this entire term will become 0. MB we have to calculate 2 MB. L1 is 8 meter, L2 is also 8 meter. MC is 0. So now this W1 is 40, 8 cube divided by 4 plus W2 is also 40 into 8 cube divided by 4. Okay, if you solve this you will get value of MB is equal to 320 kN per meter. 320 kN per meter. Okay, so in this just one equation, no need to calculate A1 x1, no need to calculate A2 x2. Just substitute the values in this equation, you will get value of MB. Now calculation of reaction, again we have to follow the same procedure which we have followed in a previous example. So you have to consider each span separately and you have to calculate RA and RC first and then you have to calculate RA. Okay. So this is 320. This is RB, RA 40 kilonewton per meter, and this is 8 meter. Okay. Now, see, if you take the moment at B, you will get RA into 8 plus 320 minus 40 into 8 into 8 by 2. You will get value of RA. So this RA is 120. Okay, see this RA into 8 and clockwise movement. 320 clockwise movement and 40 into 8 into 8 by 2 anti-clockwise movement, so minus. Okay. Similarly, if you try to calculate for RC, 40 kilonewton per meter. See, RC into 8 anti-clockwise, then this 320, this is also anti-clockwise, and 40 into 8 into 8 by 2 equal to 0, you get RC also as a 120 kilonewton. See, this entire beam is symmetrical, definitely RA and RC will be same. Okay, now what is RB? RB will be total load minus RA minus RC. Total load is 40 into 16 minus RA minus RC. You will get RB as a 400. RB as a 400. If we superimpose the bending moment over here, bending moment is 320. This is negative moment, this is positive, this is positive. Okay. Now this is what the case of particular case of UDL. Okay. Now we'll solve one more example based on the 3 moment theorem. Okay, I will read the numerical for you. Please note it down. Okay. A continuous beam ABC consists of two span AB and BC of length 4 meter and 6 meter respectively. See the figure. A continuous beam ABC consists of two span AB and BC respectively. Okay. So AB length is 4 meter and BC length is 6 meter. BC length is 6 meter. Now, this span carries a point load. AB span carries point load of 40 kilonewton at 2 meter from A. AB span is carrying a load, point load at 2 meter distance from A. Okay. Now find the reactions at support and draw bending moment diagram for B. Okay. You have to find out the reactions RA, RB and RC. And bending moment diagram for beam. You have to use 3 moment theorem again. Okay. So for that again see, AB is carrying a point load, but BC there is no load. So first step is to draw the pre-bending moment diagram for the given beam. So pre-BMD for given beam. See, there is a point load. So if the point load is there, you have to use the formula. See, if the point load is there at center, formula will be WL by 4. Maximum bending moment will be WL by 4. If point load is eccentric, means suppose this 40 km is at 3 meter, then maximum bending moment 3 BMD will be WAB by 4. WAB by L. WAB by L. If the eccentric load is there, now the load is at the center, so WL by 4 is okay. So W40, L is 4 divided by 4. So it is 40. And its apex will be at the center because the load is at the center. आपल्याला कॅल्क्युलेट करताना लागला a1 x2 and a2 x2 calculation साठी लागला. So now at BC there is no load. So what is the bending moment? Free bending moment 0. Free BMT for BC it is 0. Okay. So write down the equation, 3 moment theorem equation. Ma L1 I1 2mb L1 plus L1 divided by I1 plus L2 divided by I2 plus MC is equal to 6a1 x2 divided by I1 plus 6a2 x2 divided by I2. Okay. So now this will be 0. MAL1 divided by I1 0 because see A and C again are simply supported. It may be a roller, it may be hinge. So hand supports are supposed simply supported, then it will be bending moment at that particular support will be 0. Okay. If this A and C is fixed support, so there will be some moment. Okay, support moment. And A and C both are simply supported, so moment will be 0. Okay. आता फक्त असा एक एरो दाखवला म्हणजे सिम्पली सपोर्टेड आहे. फिक्स सपोर्ट असेल तर तुम्हाला हे अशा एरो दाखवलेला सो सिम्बॉल ऑफ फिक्स सपोर्ट. सपोज देयर इज हिंज देन आल्सो सपोर्ट मोमेंट इज 0. देयर इज रोलर सपोर्ट मोमेंट इज 0. But if it is end, if there is intermediate support जर रोलर असेल हिंज असेल तर तिथे मोमेंट येणार. ओके. So at MB is also simple support, but it is intermediate. B support is also simple support, but it is intermediate. So definitely there will be movement. Okay. So 2MB. So what about I? I is constant throughout ABC. So moment of inertia term will get cancelled from all the sides. Okay. So now L1 is 4, L2 is 6, MC is again 0. So now 6a1 x1 divided by L1. Okay. So a1 x1 will calculate a1 x1. a1 is 1/2 base 4 meter height 4. What is x1? x1 will be means x1 is the CG from the A. This will be at 2 meter. Symmetrical triangle है, so its CG will be at the center 2 meter from A. So multiplied by 2. So this A1 x1 we have the value of A1 x1. Just substitute here 6 A1 x1 divided by L1 is 4. I1 get term get cancelled. What about A2 x2? As there is no bending moment, bending moment diagram is 0, so A2 x2 will be 0 plus 0. Okay. So if we solve this, you will get value of MB as a 12 kilonewton. As a 12 kilonewton meter. Okay. Now we have to find out the reactions. Reaction first. RA, RB, and this is boom B moment 12 kilonewton MB. So taking summation of moment and B and equating it to 0 and equating it to 0. So R A multiplied by 4, this is 4 meter and this is 2 meter minus 14 to 2 plus 12 equal to 0. So we will get RA as 17 kilometer. RA as 17 kilometer. Okay. Then similarly we will calculate for second RC. There is no road, only this 12 kilometer meter movement will be there. So RC into 4 plus 12, both are anti-clockwise, equal to 0. If you take the moment about P, RC into 4 and this RB. Okay, taking the moment and so from this we will get RC minus 2. Okay. Now what about RB? RA plus RB plus RC is equal to 40. Total reaction is equal to total load. RA plus RB plus RC is equal to 40. So from this you will get RB as a 25. So this is 17 RA, RB 25, and this is minus 2. Minus 2 means it will come. Okay. So this is how you can solve. They asked to find out the moment and support reactions. You have calculated the bending moment 12 kilonewton at the middle and 0 at both the ends. And reactions RA, RB and RC we have calculated. Okay. In next lecture also we will solve some more examples on C moment theorem. If you are having any doubt you can ask, okay, by WhatsApp as well as you can call me for any queries. Thank you.